Hello, I'm Craig. Let's talk about cars. So this week we're talking about steering and suspension systems. And as you look at this picture right here of a subframe, you can see not only brakes, like these obviously sweet red calipers jump out at you, but you can see a lot of mechanical components linking this side to that side. You got this here, you got an A-arm here, this doohickey mechanism, stuff we're going to talk about. What is this? What's this going to cross here? Um, Basically all of this steering and suspension. One, why do we have it? Which you can probably guess why we have steering and suspension. But two, how does it work? How do we identify parts? Are they all created equal? Do they all look the same? So these are some of the things that we're going to talk about today. And I know you kind of have an idea what the purpose of suspension is, but just to redefine it, basically suspension is going to dampen those oscillations. And we'll get to more of that later, but manufacturers achieve this in different ways and in different ways over the years. Okay, so if we look back through time, you can see different types of suspension systems. Solid axle. Okay, right here we got this old, looks like Model T Ford. This big solid beam that connects one wheel hub to the other. Okay, they call them kingpins here. This little pin right here. Good load capacity, real strong, but poor dynamic characteristics. Basically meaning if I hit a bump on this wheel, what's going to happen to this wheel? Is it going to be affected or not? And the fact that they're connected by a solid beam tells you it's going to be affected. So this vehicle is going to ride pretty rough. It has one spring. There's a leaf spring right here we'll talk about later to dampen those oscillations and road vibrations. But again, one spring and one solid axle, everything's connected to. That's going to be a rough ride. So the next basically generation of this was a twin I-beam. So instead of having just the one solid I-beam right here, you'd have two I-beams that are long, but they're still kind of independent. Okay, so good load capacity and travel, poor tire wear and handling, and kind of here's why. It's hard to see from this picture, but if you take a look at this wheel right here, it's got that same kind of kingpin that the solid axle had up here, but instead of going straight to get connected to this side, it's going to go up and it's actually going to be connected up here. Okay, so this pivots right here and goes over here. So it kind of anchors up here, pivots off this point, and then goes over here to go up and down. So as to think of a big radius, this goes over to this point, not the other wheel, right there. So this I-beam right here can go up and down in a radius, and that's why it's going to give you good kind of a good ride, but poor tire wear and handling. Because as the vehicle or the wheels go up and down, it's going to give an arching travel. Okay, so you're going to get tire wear. And if you look at this side, it's connected to a pivot point that's hidden behind this axle here and anchored off this mount right here. So again, it gives you kind of overlaps these I-beams instead of one big giant I-beam. This gives you the real true kind of iteration into independent front suspension. The true independent front suspension that came out, the SLA, short arm, long arm, real common among GMs, and you can see right here is an example of an SLA front independent suspension system. If this wheel right here goes up and down, what happens to this wheel over here? It doesn't necessarily go up and down. Okay, they move independently from each other completely. So you have basically a control arm, A-arm right here, upper and lower A-arms, hence the short arm, long arm. One's short and one's long. Right here's long and here's short. So as you can see, it's going to pivot right here and right here. Okay, these bushings, and then there's a ball joint right here. We'll talk more about this later, but this allows the wheel to go up and down and turn left to right with these mechanical components. So again, gave good tire wear, good decent load capability. Ride was nice, handling was good. This is a good front end, but could be expensive and was used for what was called a ladder frame kind of design. So this is when you had cars with big giant frames and you bolted a body on top. When we moved into the unit body construction, we had to come up with a new design. And I say I didn't come up with any design, but the engineers came up with McPherson strut, no doubt named after McPherson. So good handling characteristics, lightweight, cheap, easy to build, could be utilized in a unit body construction, which again, if you don't know what that is, basically you had ladder frame where you had these big boxed frames and then a body bolted on top of it. In a unit body construction, you're going to have basically the body is pretty much the frame. You can still have subframes, but the body is it is part of the frame. Like it's all built into one unit. It's structurally sound, where on a ladder frame system, the body was just a bunch of panels bolted together on top of that frame. The structural integrity was the frame itself. In a unit body, the body is part of the structural integrity. So you had a different system, which we'll talk more about later, this McPherson system right here. Okay, so got rid of that upper control arm, and you're going to have this whole McPherson strut knuckle assembly right here. It still pivots off a lower control arm and a ball joint, but this system is going to have a strut instead of shocks and springs. So we'll talk more about that in a minute. That's kind of the generation, big, broad characteristics of suspension systems. So purpose of the suspension, again, turn wheels left and right, maintain alignment angles through wheel travel. Remember I mentioned, we go back, this twin I-beam cannot maintain alignment angles through wheel travel. As the travel goes up, it's an arching radius because it's pivoting off that, and that's going to change camber, among other things, but mainly camber. So again, that suspension system cannot do that. Another purpose of the suspension components: provide for a nice ride on various road surface, support the weight of the vehicle. That's often very, very important, right? You don't want it to break. If you're driving a truck, you're going to have a rough, rugged, heavy-duty suspension system. The compromise, like anything in engineering, you can't have it all. As the adage goes, you can't have your cake and eat it too. So if you want a nice ride, you may have to sacrifice some strength and integrity of your suspension. Vice versa, if you want a really strong, rigid suspension, you may not have the nicest ride in the world. So springs, it all kind of works off springs. Basically, they're designed to maintain the vehicle ride height, support the vehicle's what's called sprung weight, and supply the desired amount of ride comfort. And again, sprung weight is everything just that. Everything is sprung above the spring. So whatever the spring is supporting in the car, that is known as sprung weight. So think about what unsprung weight is. That would be like your wheels, right? Lower control arm. Depends on the suspension system, but tires, wheels, brakes, etc. Those are not supported by the springs of the vehicle. And springs come in different shapes and sizes. We have leaf spring, torsion bar, coil spring, progressive coil spring. You can have air springs. There's some other ones we won't talk about today. But basically a spring is just a big piece of flat metal stock, harden it, make it tough, and you have a leaf spring. Okay, so classic old school spring system. It's right here. Here's your leaf. Okay, so it's arching flat metal stock, a bunch of springs. It could be a leaf pack or it can be a monoleaf. And they're going to be anchored up here to the frame, and then a pivot point back here. And then underneath this spring is all of this unsprung weight right here. Again, not supported by the spring of the vehicle. The rolling wheels and axle of the vehicle right here. So the whole body up here, the frame, it's all sitting on the spring. The spring sits on the axle. Axle shifts the weight over to the wheels and over to the ground. So as you hit a bump, this goes up and down. This spring, this big leaf spring, is going to absorb that. Right, it's going to absorb some of those bumps as you go down the road. Although it'd be really rigid and real bumpy. If this was physically bolted, hard connected to the frame and body, little bumps here would transfer up here. So this spring is going to accommodate that movement. So to make a leaf spring weaker, use less leaves or longer leaves. To make it stronger, use more leaves or shorter leaves. Again, making it rigid is going to make it stronger. And if you want it softer or weaker, I guess you could say, you can make them longer and more flexible, less springs. Okay, so take a piece of round metal stock, harden it a bit to make it tough, and you have torsion bar. Now, torsion bar spring system is kind of hard to explain off a picture, and I'll do my best. Normally, I can show you on a vehicle in the school, or I might link a video at the bottom of this on how a torsion bar system works. But here's basically it. It's called torsional force. You have this rod right here, this bar, and it's going to be anchored. You look down here, is this hexagonal hole right here, or octagonal hole. I can't see how many sides there are. Probably hexagonal, I think. So that bar goes down into the lower control arm right here, and the bar itself has hexagonal shape to match the hexagonal hole on this lower control arm. Okay, so think about the vehicle. If it's up in the air, this lower control arm has got a bushing right here, and it's also connected to the wheels over here. So when the vehicle lifts up by the frame, the wheels sag, this bar goes down, we slide this big torsion bar into that hexagonal locking hole, and then we bolt this end right here to the frame, right here. So this end gets bolted and stationary to the frame, essentially. Right here's a set bolt right here. There's a bar that goes across and locks it in place. So then we lower the vehicle down, this control arm, which was down here hanging because the wheels kind of hang down low. When we bring the car down, the wheel is going to go back up, and as it goes back up, it's twisting that hexagonal locked area, and it wants to twist this whole bar but it can't. It can't twist the bar because it's locked in over here to the frame. So what happens is the bar twists and it has a torsional force that wants to untwist back to the condition and shape it was in prior. What that does is that's going to push this control arm down. So as you go through bumps up and down, this bar is twisting and untwisting to accommodate those bumps. Again, kind of hard to explain talking to you through a picture, but I will link a video and this will all make sense. So to make it weaker, use a smaller diameter bar or longer. To make it stronger, use a larger diameter bar or shorter. So take out the torsion bar, wind it to a round shape, and you have a spring. So we have coil springs right here. These ones are easier to explain because you can kind of picture how this mechanism is going to absorb weight, right? If I push it, it's going to compress, it's going to want to push back. The torsion spring works the same way, but it works off a twisting force. I twist it, it's going to want to twist back. This is a push, and I load it by pushing and squeezing it. It's going to want to go back to its other position. So that gives us that spring, that push to absorb those bumps and whatnot. So this one over here, coil, you got it just all even shape. This one right here is progressive, meaning the spring force isn't equal, it isn't linear. It means this section right here is going to have a different spring force than the top. Like this one over here, this is going to have a different spring force than up here. Okay, this might be weaker and lesser. They have different rates. So as you go down the road, it rides nice, but when you turn, it can get firm. So progressive coil springs become popular for that reason. To make the coil spring weaker, use a smaller diameter coil or longer coil. To make it stronger, use a larger diameter coil or shorter coil, much like the torsion that we talked about a moment ago. Okay, so that's basically it for springs. Then we have what's called shocks or struts. So a shock or strut is responsible for dampening spring oscillation. Think of it this way. If you're driving down the road, like that video you watched earlier on the Bose suspension, car's driving down the road and you hit a hole, like a pothole or bumps in the road or speed bump, what happens to the car? That wheel pushes up in the spring, pushes the car up, and the spring's going to push it back down, pushing against the road, and this oscillation kind of happens as you bounce down the road. Well, to dampen that, to kind of prevent that oscillation, we attach shocks or struts to the spring in the vehicle, the frame, to kind of dampen that. So it kind of wants to resist movement, which you're like, isn't the point to allow movement? And that's true. We put in different parts with different rates to accommodate those different desires, or different needs, different wants. So as you go down the road, the spring allows you to be kind of bouncy and bumpy and disconnected from the road, but we're going to attach a shock or a strut, which is going to try to fight that oscillation, that bounciness. The end result is a smooth ride that's comfortable and handles well. So decent shocks and struts will give you a better ride quality, better handling, your tires and brakes will last longer, etc. So they are crucial. Let's take a look at what they look like. So the difference between a shock and a strut. Shocks are kind of standalone. Again, you notice this leaf spring, so the weight of the vehicle is on, we'll go over here, this leaf spring right here. The weight support of the vehicle here to the axle housing, over to the hub, and then down through the tires. Well, this shock is connected from the frame of the vehicle down to this. So a sprung weight to unsprung weight between where the springs are. That's going to, as a plunger in here in the shock, that's going to fight moving up and down. There's a plunger with some oil in these, and it's going to want to fight that movement up and down, which helps dampen the oscillations of a spring bouncing up and down. The difference to a strut over here is it's inside this assembly. So the shock is inside this spring strut combo right here. So it's kind of a spring, it's got a bearing up top here, and inside this is the shock. And so that's also known as a strut. Okay. Let's see. I'm actually going to stop the video right there. This is the end of part 1. So I'm running out of my 15-minute window, and I will see you in part 2.